well, what's in it for the stakeholders in the value chain? Miscanthus can give alternative income models for farmers. It grows well, we told, on marginal soils. It yields up to 20 tons of biomass per hectare. Depending on the products that it's used for, it yields 170 till 180 euros per ton of dry matter, but it's not ready to market. As a raw material for construction, the production chain needs to be further developed and acreage needs to be expanded. Miscanthus is a relatively easy crop to grow. Apart from harvesting, it requires no attention. It's labor extensive. It's highly resistant to drought and flooding, except for the first year, as Reind experienced. Miscanthus has a low environmental impact and a positive effect on the soil structure. No soil cultivation takes place. No plant protection products are required. The root structure, those are the rhizomes, the root structure improves soil quality. Organic matter accumulates by the annual fall of the leaves, and it can even extract PFAS from the soil. These are absorbed by the plant, and 56% of the particles are broken down. Recent research has shown. And it's a suitable crop for marginal land. Erik already told some about this, field margins, fallow land, buffer strips. It can be used around industrial sites to conceal it from view. For example, in the Netherlands, we have the airport of Schiphol with a lot of geese around that bring a lot of problems when there's just grassland, but the Miscanthus there, they don't like the Miscanthus, the geese don't like them. So there's no nuisance from feeding the geese. There are closed loops. We saw some closed loops in own fuel demands. A farmer, a cattle farmer that also grows Miscanthus, and he uses this for the biofuel to warm the stables of the cows. We also see it be used on land that's requiring some rest, and as I told, polluted land. So in order to, within the value chain, to make new building materials, it's very important that we make some risk diversification for those building models. So if in one year some crops are failed, we can use different crops, and multiple fiber crops can be used in the production. So, yeah. Well, those are some of the what's in it for me examples.
Just to summarize really the key takeaways of this presentation, I hope many of you have been able to really garner some new information, new intelligence on this crop. But the key takeaways that we believe are really lessons learned for us is the important part of the value chain. You see the bottom one, risk on bio-based value chains need to be shared among parties involved, which requires trust. It's very important and something that an orchestrator really needs to play a big role in. The top one, different products require different solutions. It goes into what type of application do you use and how do you really approach the value chain for that solution. When it comes to concrete, for example, concrete is heavy. So if you want to use that, you need to develop a business or a value chain that is really embedded in the region, because you don't want to drive too long with all those heavy materials. So yeah, that's basically the key takeaways for now. In these final few minutes, we want to give you some space on any questions. You can use the Q&A bar, or you can use the Mentimeter for these questions. We'll be on here for a few minutes still, but for now there are no questions yet. So anyone.
And that material will remain active for a while. So if our participants submit their questions, then I take these questions.
So off screen, there is a very capable person here called Gian. He just mentioned that the Mentimeter will be available for a while if you hadn't heard it. And any questions that you put in here, they'll be forwarded to us later on. So we will still be able to answer it. So scan this if you have any questions. Zie je een nieuwe post schrijven, dus klikken. We have one question. What about fire risk when using Miscanthus boards? So this is a very specific question. Thank you. Fire risks are something that is very, very, very important when applied in construction. Because fire risk, if something can take flame, it's a no-go for any constructor. At the same time, any product that is developed needs to have some you call that a program of demands. When you design a product to be used in construction, fire hazard is something that you really need to take into account. And there are ways to make a bio-based product fireproof. For example, there are fire retardant production materials. There are ways to encapsulate it into fire retardant other materials that can really protect it from flames. So there are many ways to approach this, but it is something that you really need to think about. You can't just make a product and hope someone will buy it when you don't think about these things.
No, and as you can see on the screen now, right on the bottom, there are already boards on the market from Orange Elephants, and they passed the fire tests. Otherwise, they weren't available on the market now. So I don't know what additive they put in it to make it resistant. Maybe it's magnesium or other additives. I don't know for sure, but that's some of the applications that needs to be tested before it's market ready.
Yeah. Then one question is, will we get the presentation? I'm looking at Gian. He nods, so yes.
Not only presentation, but also recording of this webinar will be available on our website soon, as soon as possible.
If maybe you haven't heard it because the mic is over here, but the webinar will also stay available on our BBoBB website, so you can watch it back as well. What's the second question? What are the next steps after the project ends, and will there be follow-up initiatives or projects? So that's a very good question because yes, basically the answer is there will be follow-up initiatives or projects. It's not clear as of right now in which exact project will be developed in what type of fashion, but anything that we develop here is very important knowledge for the broad sense that we have here in the regional value chain development. There's a very strong ecosystem here in the north of the Netherlands working together on getting these types of products further into market. So any knowledge that is developed within the BBoBB project is utilized in those types of projects. Right now, we're working with construction companies to actually apply Miscanthus in the concrete application that is mentioned within this value chain. And that type of application would not have been able to cross our minds if we hadn't done this project, for example. So we're actually already working on the next step. And at the same time, we need to keep sharing knowledge within regional contexts, such as we're doing in this project. So we're collaborating with many other regions on these types of developments, and we want to keep doing that, definitely. So I'm not sure what exact follow-up will be right now, but there are definitely going to be follow-ups, such in the regional context, but also in the European context, which is very important to work together on.
And here we have another question. Are there any specific demands for soil type? The Miscanthus crop is not that demanding. It grows on nearly any soil. So it's on that, it's quite an easy crop, probably, but I don't know for sure the amounts. The yield differs a bit from different kind of soils.
Yeah. I think this question is, are there any accredited certification systems available in terms of EPDs for using, e.g. as filler in concrete to reduce CO2 footprint in end product? This is a very interesting question because it exposes some vulnerabilities in the type of approach that is involved with an EPD. For an EPD to be constructed, you need to do a life cycle analysis. And when you do this, you take into account what is the end of life scenario for a product such as using a Miscanthus in concrete. And the current approach on that is that it cannot be reused at all, cannot be recycled at all, because the industry standard is using clean concrete, fully clean concrete. When you look at that, it usually will result in having a worse environmental score in an EPD than regular concrete, while there is encapsulated carbon in the material itself, embodied carbon. So you can feel that it doesn't really, it's not really correct. But it does show you something about, okay, when you use these types of certification methods, you need to think about what is presented in there and what is really necessary to get the value chain up and running, to reach our climate goals, etc. At the same time, it also exposes how there is a vulnerability when using these types of crops in these types of applications. Because when you do use concrete such as this, you can't reuse it in standard concrete, but you can make a closed loop in the region with this type of concrete that you can reuse and recycle. So good question. It sparks a lot of interesting discussion. I think there's one final question here. Thank you very much. No problem. For this inspiring and informative webinar. I really enjoyed learning more about the BBoBB project and the potential of Miscanthus. Great question. Well. Thank you very much, everyone.
Yes, thank you very much for joining us. And we hope to see you on the next webinar. I don't know the date, but we will put it on LinkedIn.
Yeah. So we'll be seeing you all later on.
Yes.